Good morning, children. Welcome to class 7 science once again. Children, I hope you all are perfectly all right and stay home. Children, in a previous videos, we were discussing about chapter 14, that is electric current and its effect. In this chapter, we have discussed about electrical components and their symbol. Also, we have discussed about heating effect of electric current, in which we have seen that short circuit, overloading, electric fuse, MCB. Okay, so that we already done. Now the last topic of the chapter, that is magnetic effect of electric current, will take today. Okay, clear about this? So children, magnetic effect of electric current. Children, when electric current flow through a wire, it behave like a magnet, and this is called magnetic effect of electric current. Okay, I repeat once again. When electric current flows through a wire, it behaves like a magnet, and this effect is called magnetic effect of electric current. Okay, so you have learned that the needle of magnetic compass point in north south direction when at rest. When a magnet is kept close to current carrying wire, the needle get deflects. Okay, this is also due to the magnetic effect of electric current. Okay, now to prove this, we'll perform an activity. When school reopen, here I am just discuss with you the activity. In this activity, children, we take a cardboard tray from a matchbox, then wind an electric wire a few times around a cardboard tray. Okay, so around the cardboard tray will wind an electric wire. After that, place a small compass needle inside it and connect the free end of the wire to an electric cell. Okay, switch will also take. Then after, when switch is on, the compass needle deflects, and the switch is off, the compass needle come back to its original position. So children, this show that when electric current flow through a wire, it behave like a magnet. Okay, like when the switch is on, then the electric current flow through a wire and it behave like a magnet, and the compass needle deflects. Okay, when we switch off, the compass needle comes back to its original position. Okay children, so this show that when electric current flow through a wire, it behave like a magnet, and it is magnetic effect of electric current. Okay, now this is, you can see here, that is a cardboard tray in which we have put in a compass needle there. Okay, a cell, we also have electric cell, then switch is there. So if we switch on, then the current is running in the wire and the needle will deflects. Okay, if we switch off, then no supply of current in that circuit and the needle gets back to their original form. This is the magnetic effect of electric current. Okay, clear? Now next, the example of magnetic effect of electric current is electromagnet. Okay, electromagnet, children, first see the definition. When electric current is passed through a coil of insulated wire wound around an iron piece, it becomes a magnet, and such magnet is called electromagnet. Okay, like very simple. We have a nail, and around that we have put it a insulated wire. So if we provide electric current in the insulated wire, so the nail should behave like a electromagnet. It attract the copper things, it attract the iron things, so it behave like a electromagnet. Okay, here we have some activity. In this activity, children, you will see that we have a nail, then coil of insulated wire that is around the nail, a battery and a switch. Okay, we'll also put some pins here, okay, near the nail. When we switch on here, the electric current run through the through the insulated wire in the nail. So that's why the iron nail behave like a electromagnet, and they attracts the pins near the nail. Okay, so this proves that this is the magnetic effect of electric current. Okay, clear about this, children? Now see this activity on your screen. Again we'll discuss. Okay, first, when a piece of insulated wire around an iron nail in the form of coil, okay, this we have in the figure. After that, connect the free ends of wire to an electric cell through which, okay, here we have two ends, 1 2, then one end of the wire we connect to the battery, and one end of the wire we connect to the switch. Okay, now then place some pins near the nail. Okay, after that, when electric current is passed, the iron nail become a magnet and attracts the pins. Okay, so children, when electric current is switched off, the nail loses its magnetism. Okay, and this effect is called magnetic effect of electric current. Example, electromagnet. Okay, clear? Now children, the various uses of electromagnet in our life, like electromagnet are used in electric appliances like electric bells, electric fans, mixers, washing machine. Okay, and electromagnets are also used to separate magnetic material like iron from metal scrap. Okay, so here are some uses that we have seen of electromagnet. Clear, children? Electromagnet. Now next, that is electric bell. Okay, electric bell is one of the most commonly used application of electromagnets. It works on the magnetic effect of current. Okay, clear about this, children? I repeat once again, electric bell is one of the most commonly used application of electromagnets, and it works on the magnetic effect of electric current. So as you see on your screen, the electric bell has a coil of wire wound around a piece of iron which act as a electromagnet. Okay, electric bell, that is coil of wire and a piece of iron that behave like electromagnet that we have seen in the previous slide. So an iron strip with hammer is kept close to the electromagnet. There is contact screw near the iron strip, and when the iron strip is in contact with the screw, the current flow through coil and becomes an electromagnet. Okay, so we can say that, children, the electric bell, that is consist of electromagnet, springy iron strip, a hammer, a gong, and a switch. Okay, clear about this? Next, the procedure. If we pulse the iron strip and the hammer at the end of the strip strike the gong of the bell and they produce the sound. So we know that the electric bell, that is consist of electromagnet, iron strip, hammer, gong, a switch. So when switch in the on position, the iron strip and the hammer at the end of the strip strikes the gong and they produce the sound. Okay, when electromagnet pulls the iron strip, it also break the circuit and iron strip come back to the original position, and the process repeats and the bell rings. Okay, so children, that's all for today in this chapter. I think chapter is finished. Now we'll see some important points of the chapter. Okay, a very important point that I'm saying to you, the figure you can see first, that is of electric bell, a bell, striker, contact, spring, switch, gong. Okay, now in last we'll see the summary of the chapter. Okay, in summary, children, important points are there. So the first point is electric circuit is the path along which electric current flow. Okay, so electric current flow in the electric circuit. Various components in electric circuit are represented by their standard symbols. So various symbol are there, like symbol of battery, symbol of switch, symbol of wire, symbol of bulb. Okay. Next, third, conductors have low resistance and allow electric current to pass through them. Okay, while insulator have high resistance and do not allow electric current to pass through them. Okay, conductor, insulator is clear, very simple. So children, next point, when electric current is passed through a wire, it's get heated due to heating effect of electric current. We have seen in the electric iron, we have seen in the geyser, we have seen in the electric room heater. So when current is passed through a wire, a filament, then it behaves like a heating. It's get heat up. Okay. Next point, electric fuse. Electric fuse, that is a safety device which melts and breaks the circuit in case of overloading. Okay. Next, a wire carrying electric current produce magnetic field. Electricity can also produce the magnetic effect because the electric wire behave like a magnet. So this is the magnetic effect of electric current. Okay, clear about this, children? Any confusion? Now if any confusion, you will discuss in live class. So in this chapter, children, we have discussed the various things. I repeat once again. First, we have discussed the components of circuits and their symbols. Second, switch. Third, battery. Fourth, electric circuit. Fifth, conductor and insulator. Sixth, heating effect of electric current and their application. Next, short circuit and overloading along with the electric fuse, MCB, and last, children, we have discussed about magnetic effect of electric current. Example of magnetic effect, that is electromagnet and electric bell. Okay, so chapter finish. I hope you have learned properly. If any problem, we'll discuss in live class very soon. Thank you.